Hello, this is 1-2, Operations with Integers and Order of Operations. Today's topic will cover the number line and PEMDAS. Alright, so first thing you should be familiar with is the number line. So if I were to draw a number line here, for example, say 0 is here, these are positive integers. All the positive numbers. We're talking about integers today. Integers, again, are all numbers that can be written without a fraction or a decimal, and these would be negative. Alright, so today we're going to talk about how to do operations with integers. So, for example, say we had something like 5 minus 3. How would we represent that? Of course, we know that is 2, but how would we represent that on the number line? We'd start at 5. We're subtracting 3, so we're going to the left 3 times. 1, 2, 3. This is 4, 3, 2. And we land at 2, so that's our answer. What about adding? What about 2 plus 3? We know that's 5, but how do you represent that on the number line? Well, we start at 2, we're adding 3, so we go to the right 3 times. 1, 2, 3. Great. Alright, now we're going to learn about what adding negative and subtracting negative integers mean. Say you see something like this. What does that mean? Well, what you need to remember is that two negatives make a positive. You should write this in your notes so you can remember this for homework and tests. So what exactly does this mean? Well, we have two negatives here, one here and one there. So we can replace it with a positive or a plus sign. So 5 minus negative 3 is the same as 5 plus 3. And again, we can represent this on the number line. 5, 1, 2, 3. We land at 8. This is plus 3. Right. Alright. Well, what about the opposite? What about 5 plus negative 3? What does that mean? Well, here we only have one negative sign, so we can't replace it with a positive sign. So here, basically, is 5 minus 3. You can think of 5 plus negative 3 as negative 3 is happening to the 5. In other words, you're going left 3 from 5. So, how do we represent this? Well, we start at 5, and we go 3 backwards. 1, 2, 3. And we land at 2. So, 5 plus negative 3 is 2. Now, what if our answer is negative? How does that work? Well, say something like 5. Ooh, doesn't look very good. 5 minus 8. What does that mean? Well, we start at 5. Here's 0. And we have to go back go to the left 8 times. So here's minus 5, and do another minus 3 to get 8. And if we do the jumps, 1, 2, 3, this is negative 1, this is negative 2, this is negative 3. So 5 minus 8 is negative 3, or 3 less than 0. Now here's a tip when you do these types of questions. Again, 5 minus 8. From a glance, you can see that this number will obviously be negative because the number you're subtracting is bigger. You only have 5 and you're taking away 8. From a glance, you can realize that this number is negative. So what you can do is already put a negative sign there and then flip it. You can do 8 minus 5. Well, what is 8 minus 5? That's 3. So you put 3 there, and you get 8. 5 minus 8 is negative 3. Now let's use this principle and try to solve a question. Say we have 10 minus 25. What is that? I encourage you to pause the video and try to do it on your own. Alright, assuming that you paused the video and given an attempt, let's do the question together. Well, first of all, we see that we only have 10, we're subtracting 25, which means that the answer will obviously be negative. Then we can invert it. 25 minus 10 is 15. So 10 minus 25 is negative 15. Do not forget this negative sign when you're using this tip. Alright. You'll have more practice on the homework, so we're going to skip over to multiplication and division. So you also still have to remember that two negatives make a positive. Remember this. If this is not in your notes, make sure to write it down right now. What does this mean? Say we had 2 times negative 5. Well, we know that 2 times 5 normally is 10. And now we have to count up how many negative signs we see. Well, we see 1. What does that mean? It means that the answer will be negative. Negative 10. 2 times negative 5 is negative 10. You can write this down as well. Odd number of negative signs means negative, and an even number of negative signs means positive. So for example, if you had negative 2 times negative 5, you'd have an even number of negative signs. That would result in the answer being positive 10. Let's do some examples together. So you had the question 3 times 2, negative 3 times 2. What does that equal? Well, first of all, let's count up the negative signs. There's 1, and 1's an odd number, meaning the answer will be negative. Alright, now we can do the question as if negative signs weren't there. What is 3 times 2? Well, it's 6. So the answer to this question is negative 6. Negative 3 times positive 2 is negative 6. Let's do one more. What is negative 10 times negative 5? Notice I have nothing here. This means times or multiplication. If there's nothing there, we can assume that it means multiplication. Well, looking at this question, we can see that there are two negative signs. And since 2 is an even number, the answer is positive. So we don't have to put a negative sign there. Now we can do the question normally. 10 and 5. 10 times 5 is 50. So negative 10 times negative 5 is positive 50. Alright. Now what about 20 divided by negative 4? Well, multiplication and division follow the same rules. If there's an even number of negative signs, then the answer is positive if it's even. If it's odd, it is negative. Well, again, this means divide. And 20 divided by negative 4, since we see only one negative sign, which is an odd number, the answer is negative. So we put a negative sign here. And 20 divided by 4 is 5. So 20 divided by negative 4 is negative 5. Alright, now we're going to talk a bit about order of operations. We follow what is called that's not good. PEMDAS. You may have heard of it before, and it stands for parentheses, exponents, multiplication, division, addition, and subtraction. Going down like this. Of course, you may not know what exponents are. Parentheses, you should know. These are parentheses. And what I don't like about this model is that it puts multiplication above division when they're in reality on the same level. And they also put addition and subtraction on different levels. So my modified version looks like this. PEMDAS, like that. PEMDAS. So what does this mean? Well, if we see parentheses, we have to do that first. And then, after we do all the parentheses, we go to the exponents. After we do all the exponents, we do the multiplication and division from left to right. And then only then do we do the addition and subtraction from left to right. Let's see an example. For example, say we had 7 plus 4 times 2. You may be inclined to go left to right and do 7 plus 4, well that's 11 times 2 is 22, but that'd be wrong. We have to use PEMDAS. We see that there are no parentheses, there are no exponents, but we see multiplication, so we have to do that first. So this simplifies to 7 plus 8. And then, now that we see no more multiplication, no more division, then we can do the addition. 7 plus 8 is 15. So this simplifies to 15. Let's see another example. This is fairly simple. We can again use PEMDAS. we see that there are parentheses. It's right here. And we need to do that first. So that's 2 plus, what's 3 times 4? Well, that's 12. And then we said that no more exponents, no multiplication, no division. We see addition. 2 plus 12 is 14. So this simplifies to 14. Let's do one more. What about this? 3 plus 7 times 4. What is this? Well, this might be very tempting. As you can see, 3 plus 7, that's an easy 10, times 4 would be 40. However, that's incorrect. We have to use PEMDAS. Do we see any parentheses? Well, technically we do, but this doesn't actually mean anything. We have to do what's inside the parentheses, and the parentheses is already solved. Now, do we see any exponents? No, we do not. What about multiplication? Yes, indeed, we do see multiplication. Again, if you don't see anything between a number and a parentheses, it usually means multiplication. So what does this mean? We have to do 7 times 4 first. So this actually simplifies to 3 plus 28. We don't see any more multiplication, no more division, addition. That simplifies to 31. So this, instead of simplifying to 40, which is incorrect, is actually 31. However, we can do a simple modification. If we instead had parentheses around 3 and 7, and we look back at PEMDAS, are there any parentheses that we need to solve? Yes, there is. This parenthesis, we need to simplify what's inside the parentheses first. 3 plus 7, well, that's 10. Times 4, we don't see any more exponents, no more parentheses. Do we see multiplication? Yes, we do. 10 times 4 is 40. So, just adding parentheses changes the answer from 31 to 40. Alright, that's all I have for you today. There will be homework posted in the Google Classroom, and it's due Friday.